Assalamualaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Today I will be solving Chemistry Paper 1 and multiple choice questions, Paper 1-2 from May-June 2021. Let's start. Question number 1. Which statement about the Avogadro constant is correct? It is the mass of 1 mole of any element. So Avogadro constant is not the mass of 1 mole of any element. So this is incorrect. It is the mass of 6.02 into 10 raised by 23 atoms of any element. So this is again, it is not a mass. This is not a mass. Avogadro constant is the 1 mole of all element contain 6.02 into 10 raised by 23 number of particles. Not mass, then it is the number of particles. It is the number of atoms in 1 mole of neon. Yes, atoms, particles can be atom, molecule, ion, compound, all are particles. And if 1 mole of atom, 1 mole of molecule, 1 mole of ion, 1 mole of compounds that contain 6.02 into 10 raised per 23 number of particles, electrons. So these are the particles. It is the number of atoms, yes, in 1 mole of neon. This must be correct. It is the number of atoms in 12 gram of any element. So this is again not correct. 12 gram it is not a fixed value. 12 gram of any element contains 6.02. It is 1 mole is equal to 6.02 into 10 raised per 23 number of particles. This is Avogadro constant. This is also incorrect. Which equation represents the first ionization energy of iodine? First ionization energy can be defined that the amount of energy which is required to remove 1 mole of atom from 1 mole of 1 mole of electron is removed from 1 mole of electron is removed from 1 mole of gaseous atom to form 1 mole of positive ions. 1 mole of unipositive ion. First ionization energy. This is first ionization energy of iodine. This is incorrect because this is half mole. Iodine plus electron. So this is incorrect because gaining of electron to form iodide ion, negative ion. This is electron affinity. Half I2 gaseous to form iodine, such half is incorrect. So C is also incorrect. So iodine gaseous atom to form 1 mole of unipositive ion after removing 1 electron. So this is correct option. The structure represents 3 compounds each with 4 carbon atoms per molecule. Which row is correct? Which row is correct? Lowest boiling point to highest boiling point. Lowest boiling point to highest boiling point. lowest. This is carboxylic acid, OH, and 1 2 3 4 1 2 3 4 4. So hydrogen bond is there because oxygen electronegative element is there, H bond. So this is ketone, CH3, CH3. So not hydrogen bonding is there, so that's why it is ketone has lowest boiling point. ONA, this is salt of acid, ONA. No hydrogen bond, but this is ionic compound. So Y is the lowest boiling point. X is not correct. Not correct. Y. So this is ionic compound, and ionic compound have high melting point, high boiling point. This is carboxylic acid. Due to hydrogen bonding, it also has high, but less than Z. So lowest is Y. X is the lowest than Z. So this is correct. This is also correct. So B option is correct. Z again, ionic compound is not lowest. Ionic compound does not have lowest boiling point. X, this is incorrect. X is correct, but Y is incorrect. Y is correct, but this is incorrect. So B option is correct. The structural formula of allene is shown. What are the approximate bond angles of X, Y, and Z in a molecule of allene? X is 120 because sp2 hybridization is there, because carbon is surrounded by 3 atoms. So this is trigonal planar. So it is 120. Y is also trigonal planar. So this is also 120. And Z is this atom is surrounded by 4 atoms. So this is tetrahedral, and tetrahedral bond angle is 109 degree. So 90x is incorrect, 90x is incorrect, this is also incorrect. So A option is correct. 120 is correct, 109 is incorrect, 90 is again incorrect. 120 correct, 120 correct, 109 correct. So C option is correct. Flask Q contains 5 dm cube of helium and 12 kilopascal pressure. Flask R contains 10 dm cube of neon at 6 kilopascal pressure. If the flasks are connected at constant temperature, what is the final pressure? So we know PF is the final pressure and VF is the final volume, is equal to P1 into V1 plus P2 into V2. So what is the final pressure? PF is equal to P1 V1 plus P2 V2 divided by VF. So P1 is equal to 5D, P1 is equal to 12 into 5 plus 10 into 6. divided by Vf. Vf is the total volume. 10 dm cube and 5 dm cube is equal to 15 dm cube. So 12 5s are 60 and 10 into 6 are 60. So this is 120 divided by 15. Pf is final pressure is 120 over 15. So this is equal to, let's calculate, this is equal to 120 divided by 15 is equal to 8 kilopascal. So this A option is correct. Sodium chloride, water and air present represent three states of matter: solid, liquid and gas. Which row is correct? Sodium chloride, particles held in rigid structure. Particles held in rigid structure, yes, this is correct. Can easily be compressed. No. Can easily be compressed, yes. Particles stationary, not stationary, vibrating on its position. Particles move, cannot easily compressed. This is also incorrect. Particles stationary, particles move. Resistant to change of shape, yes, this is correct. Cannot easily be compressed, this is also correct. Can easily be compressed, this is correct. So D option is correct. Question number 7. The reaction pathway diagram for the catalyzed reaction and the uncatalyzed reaction between nitrogen and hydrogen is shown. Which letter represents the activation energy for the first step in the decomposition of ammonia? Activation energy for the first step in the decomposition of ammonia in the presence of catalyst. In the present, catalyst lowers the activation energies. This is the activation energy, this is activation energy, and catalyst lowers the activation energy. So this process carried out in two steps. So first step, decomposition, which letter represent the activation energy? So this is the first step and this is the second step. First step and this is second step. So this is activation energy of first step B and this is activation energy of second step D. So he asked you to identify the activation energy of first step. So B is correct. This is activation energy of first step. Nitrogen and oxygen can react to form nitrogen monoxide. What is the bond energy of the bond between the atoms in NO? So we know that delta HR bond energy is delta HR is equal to bond energy of reactants minus bond energy of product minus bond energy of product. Delta HR is 180. So nitrogen bond energy reactants, nitrogen bond energy of nitrogen is N plus O double bond to form NO. So the bond energy of nitrogen molecule is 496 plus bond energy of oxygen is 944 minus 2x 2NO. So 2NO is equal to 1440 minus 180. 2NO is equal to 1260 and NO is equal to 1260 divided by 2. So this is equal to 630 kilojoule. Mole inverse 1. So A option is correct. The equation for the redox reaction is shown. SnCl2, SnCl4, HgCl2. Which species is being oxidized in this reaction? This is 2 plus 4 plus Hg2 plus minus over here 2 plus and minus. So this is going to oxidize 2 to 4. This species is oxidized. No change with mercury over here and chlorine over here. So tin is oxidized. Which species is being oxidized in this reaction? A option is correct. 3.60 moles of hydrogen gas and 2.00 moles of iodine vapor are placed in a reaction vessel, which is then sealed and maintained at a constant temperature. The equation for the reaction is shown. At equilibrium, 3.2 moles of hydrogen remains. All reactants and products are gaseous. What is the value of Kp under these conditions? H2, I2, 2HI. 3.60 mole, 2 moles of iodine and 0 moles of HI. At equilibrium, 3.20 moles of hydrogen remains. 3.20. So by subtracting 3.20, it is 0.4. So this is change in mole. This is initial change and equilibrium mole. And 0.4 H1:1. So this is again 0.4 moles. And this is 2:1. So the moles are 0.80 mole. By subtracting this mole from initial mole is equal to 1.60 and this is equilibrium 0.80. So these are the moles at equilibrium, and Kp is equal to Hi divided by partial pressure of H2 and partial pressure of I2. So this is equal to Kp is equal to 0.80, H2 3.20 and I2 1.60. So this is equal to 0.125. Two chemicals X and Y react together in a solution to give Z. The rate of formation of product Z at the start of the reaction was measured in 5 experiments 1 to 5 using various concentration X and Y. The results are shown. Experiment number: starting concentration of X mole per dm cube, starting concentration of Y, and rate of formation of Z at the start of reaction. Experiment 1 and 2, there is no change in the concentration of X moles, but here in change in concentration of Y mole. So 0.10, doubling the concentration of Y, the rate will be increased 4 times. So by doubling, the rate is increased by 4 times. And third and fourth experiment 0.10, again 0.20 to 0.40, doubling the concentration, rate will be increased by 4 times. So there is no the rate is increased by increasing the concentration of Y. So it does not affect the change in concentration of X because concentration remains the same, but the rate is going to increase. It means the rate is directly proportional to the concentration of Y. Rate concentration Y affect the rate of formation, not directly proportional, because it is doubling and the rate is quadruple, or it is increased by 4 times. So this is not directly proportional. This is by increasing by doubling the concentration, rate will be increased by 4 times. Which statement is correct? The rate of reaction is directly proportional to the concentration of reagent X. No, this is incorrect because rate is not directly proportional to the concentration of X. There is no change in concentration of X, but rate is going to increase. So this is incorrect. The rate of the reaction is directly proportional to the concentration of reagent Y. The rate is not directly proportional to the concentration because by doubling the concentration, rate will be increased by 4 times. So this is also incorrect. The rate of reaction is not affected by the concentration of X. So this must be correct because rate is not affected by the concentration of X because rate is going to increase, but there is no change in concentration of X. So this must be correct. The rate of reaction is not affected by the concentration of reagent Y. Rate of reaction is not affected by the concentration of reagent Y, but by doubling the concentration of Y, the rate, yes, this is also incorrect because rate of reaction is affected. So this is also incorrect. A sample of silicon chloride is added to cold water SiCl4. When added to cold water H2O to form SiO2 silica plus HCl. So this is the reaction, chemical reaction. Which statement describes a mixture formed at the end of the reaction? Acidic solution with no precipitate. Acidic solution is formed but there is precipitate because silica exists in solid state, and this is aqueous. Acidic solution, yes, acidic solution with white precipitate. This is correct. So B option is correct. Neutral solution, no neutral solution because acid is there, so it is incorrect. No precipitates are there after the reaction, so it is also incorrect. Neutral solution with not neutral solution because HCl with white precipitate is, but not neutral solution is incorrect, so this is also incorrect. So B option is correct. L and M are elements of period 3 of the periodic table. The oxides of L is solid at room temperature. The oxide has a giant structure. The chloride of L does not react with water. The oxide of L is a solid at room temperature. The oxide of aluminum is solid, magnesium oxide is solid, sodium oxide is solid, phosphorus 5 oxide is solid. Okay, the chloride of L does not react with water. Yeah, AlCl3 does react with water, chloride of LMgCl2, and NaCl does not react with water. It also react with dissolve in water, does not react, it dissolves in water. Sodium chloride also dissolve in water to form aqueous solution. PCl5 form acidic solution. So it also dissolves in water, not react with water. So the argon is the only element in the period 3 with a lower melting point than M. So which is lower melting point? Argon is the only element in the periodic table 3 with a lower melting point than M. So aluminum, magnesium, sodium. So sodium is only element whose melting point is lower than M. Lower than argon. So this which formula represents a compound of L and M, so it can be C. A farmer requires a solid compound to raise the pH of the soil in field from 5.5 to above 6. Which compound could the farmer use? Ammonium sulfate is acidic salt, so it lowers the pH, not increases the pH, so this is incorrect. Ammonium nitrate again is acidic salt, it decreases the pH, not increases the pH, so this is also incorrect. Calcium hydroxide is alkaline solution which increases the pH of the solution, so C compound could be used by the farmer. Calcium nitrate is the neutral salt, so this is also incorrect. Z is an anhydrous compound of group 2 element. When it is heated, Z undergoes thermal decomposition to produce two different gases. Z, two different gases. Z has a relatively low thermal stability compared to the other group 2 compounds containing the same anion as Z. Z is an anhydrous compound of group 2 element. When it is heated, undergoes thermal decomposition to produce two gases. Barium carbonate, it is incorrect because barium carbonate on decomposition gives only one gas, BaO plus CO2. So this is incorrect. Barium nitrate can be correct. It gives two gases, mixture of two gases. This statement till this might be NO3 twice to form barium oxide plus nitrogen dioxide plus oxygen gas. Z has relatively low thermal stability. In group 2 compounds, stability increases downward. So Z has relatively low thermal stability compared to this is beryllium, magnesium, calcium, strontium, barium. So Z has a relatively low thermal stability compared to other group 2 compounds containing the same anion as Z. So it gives two gases, barium, but barium has magnesium carbonate, also incorrect. Barium is here in group 2 and magnesium is here in 2. So this must be correct because magnesium nitrate is above than barium. So Z has a relatively low thermal stability compared to the other group 2 compounds containing the same anion. So these have B and D have same types of anions, nitrate and nitrates, give two mixture of two gases, same reaction, magnesium nitrate to form magnesium oxide plus 2NO2 plus half O2. But this is magnesium is above in the group 2 and stability is going to increase downward, so magnesium has low thermal stability than the barium. So this is correct option, and this is incorrect. Magnesium carbonate again gives only one gas, MgO plus CO2. So this is incorrect. The option is correct. Which row gives, question number 16, which row gives mixture of both result in the oxidation of halide ions? Mixture 1, AgNO3 and NaCl. AgNO3 gives same results in the oxidation of halide, gives, which row gives mixtures that both results in the oxidation of halide ions? So in this reaction, H2SO4 to form I2SO2 plus H2S, and this is sodium chloride. Precipitates are formed. Silver chloride, PPT solid, and sodium. This is ionic precipitation. This is not redox reaction. So this is incorrect. This is incorrect. Bromine, this is correct because it is oxidation of halide ions. Iodide ion is oxidized. So this is incorrect, but this option is correct. Br2 and NaCl. Bromine is NaCl plus Br2 is less reactive than chlorine, so bromine cannot displace chloride ion from its solution. So it is again no reaction takes place in this case, and concentration of H2SO4 and HCl. This is concentration, this is neutralization reaction, NaCl, Na2SO4, no reaction because both are acids. So both are acids, so over here HCl is not oxidized. This is not further oxidized. Cl2 and NaBr. Cl2 is reduced and Br is oxidized. Yes, this is oxidized. This is correct. But CH3, CHBr, CH3 and sodium hydroxide. Ethanolic medium. In ethanolic medium, elimination reaction takes place. Hydrogen, bromine is lost and alkene is formed. So this is also incorrect. Bromine and sodium iodide. This is iodide ion is oxidized. This is correct. Concentrated H2SO4 and NaBr is also oxidized by sulfuric acid act as an oxidizing which oxidized bromide ion to form bromine gas Br2. So this is also incorrect. Correct. So this option is correct. Chlorine gas is widely used to treat contaminated water. When chlorine is added to water, which chemical species present is responsible for killing bacteria? Cl2 when react with water to form HClO and HCl. So this chemical species HClO ion, ClO negative ion, is responsible for killing bacteria. So D option is correct. What is environmental consequences of uncontrolled use of nitrate fertilizers? So unintentional growth, excess use of fertilizers, unintentional growth of algal plant due to excessive use of nitrate fertilizer, due to excessive use of fertilizers, nitrate fertilizers. So the spread over the surface of water uses oxygen and death and decay of, this is eutrophication, decay of death of decay of plants underwater, aquatic life underwater. Underwater. So what is an environmental consequences? Acid rain? No. Low oxygen levels in stream? Yes, this is correct. Ozone depletion? No. The greenhouse effect? No. This is so B option is correct. Question number 19. Ammonia gas and hydrogen sulfide react together to form the salt ammonium sulfide. Ammonium sulfide dissolves in water to produce an orange alkaline solution. The addition of NaOH to this solution produces a gas X. The addition of HCl to a separate solution portion of this solution produces a gas Y. NaOH to this solution produces gas X and reaction with HCl produces gas Y. X and Y could represent different gases or identical gases. NH4 SH react with HCl to form NH4Cl plus H2S and NH4 SH plus HCl, sorry, NaOH, NaOH to form NaSH plus ammonia plus water. So X and Y could represent different gases or identical gases. What are identities of X? So this is X gas, ammonia is X gas, and H2S is Y gas. So these two options we can see, ammonia and H2S. Yes, this C option is correct. A compound, to question number 20, a compound P is treated with an excess of hydrogen gas. In the presence of nickel catalyst, the product Q is fully saturated. What is the number of chiral carbon atoms in the product Q? So, with reaction of H2 gas with nickel as a catalyst, double bond is break. So the compound is like this. Double bond is going to break down. This is the compound. So what is the number of chiral carbon atoms in the presence of Q? Where is the chiral carbon? This is chiral carbon because this is surrounded by 4 groups. This is also chiral carbon. This is also surrounded by 4 different groups. This is also chiral carbon. This is also chiral carbon. And this is also chiral carbon, because this carbon, this the color, this is carbon, this is CH3, and this is H, and 2 different groups. This is carbon H, this group, 1, 2, 3, 4 and 5 chiral carbon. So this is also chiral carbon, carbon H. This is different groups, and this is different groups, and this is different groups. So this is again chiral, this is chiral H, 1, 2, third group and fourth group. So 5 chiral carbon is there. So this option is correct.